Everyone, welcome to day 20 of my daily science journey, and today I'll be again revising the problems. Guys, as you guys can see, I have a different background, so it's the reason why I didn't have a webcam for like 2 or 3 days. It's because I was just moving my desks around and stuff. So yeah, yeah. From today onwards, I will have a video on my screens. So let me just check if I'm properly streaming or not. For some reason it says up around and stuff. So yeah, yeah. From today on. Yeah. All right. Everything's fine. My audio is being transmitted as well, and let's go. I will start with top keep. I think I spent about an hour or something on this problem yesterday and still could not solve it right. It was hours 39 minutes. Sorted grouped anagram. No, it's not. Yeah, it's the same problem that I was struggling with yesterday. E3T tan 8 nat bad. Wait, what was this about? This is most frequent elements. Okay, and this is the group anagrams. Sorted stir equals dot sorted string dot and this is what something like a bed. And this is also this was a problem where I was struggling yesterday. I don't think I managed to get it to run, did I? Yeah, it runs. I thought that didn't work. Was it accepted? Yeah, it was accepted as well, but it was really slow. Uh, that's fine. Let's check the solution. What was the solution? Oh, okay. Yeah, I remember the solution. In the solution, you have to like use a trick or something. Yeah, and in number of counters, we got frequency and append it to the frequency and uh, then result. Hmm. I forgot the trick. Okay, no, like how I did it yesterday. But well, that's fine. Okay, so uh, I'll move on to encode and decode strings. This problem. I have to come back to this at a later date. Okay, it's a little opinion about this. So the problem is a product of array except self. Given an integer array nums, return any array answer such that answer I is equal to the product of all the elements of nums except. Okay, let me just restart the timer. We've got nums equal 1 to 4 and okay. So what we have to write an algorithm that turns in O of n. Writing in O of n is going to be a bit difficult, but let's see. what I could do is, what can I do? Ah, I just thought of a solution of n square, but that's going to exceed the time limit, so I'm not going to attempt even attempt that. 1 2 3 and 4. The first index, age. I know that I have to use as map over here, but how can I use it? How do I solve it? One. There's another restriction, right? Can you solve the problem in of one extra space complexity? The output I does not have an extra space for the space complexity. I can't use use division operator, right? Yeah. Without using division operation. Hmm. I could take all of the multiples, but that would not work. Okay, so like just loop through the array, and if yeah, I don't think I can do it anymore. And how did I do it previously? Obviously, I can do it in 2 of n with using division operator, and of n squared without using division operator, but I have to solve it in O of n without using the division operator. So this is obviously very difficult. I'm still thinking I could put off them in an array, use a dictionary to store off their product, which will not work. There has to be a trick, right? I followed the trick. I can do it in of n and of n square, but I can't do it without using division operators. Okay, prefix equals 1 times n, suffix equals for n range, prefix, suffix. For I in range, n minus 2 minus 1 minus 1. So what's the deal with the prefix and suffix? Prefix I, okay, equals prefix I minus 1 times nums I minus 1. What? So the prefix I is going to be equals to the, okay, let's think about it from the very first iteration. So the 0th index of a prefix will be equals to prefix -1. So it would be 1 because everything in the 1 times num I minus 1 would be -1, so it's 4. Prefix I equals 4, and prefix, so okay, prefix 0 equals 4, prefix 1 equals prefix I minus 1, so it's 4 times, that's 4 times I minus 1. It's 4 times 4 times 4. Prefix 1 equals 4 times 4. So x first is also 4. Okay, and then we've got prefix I minus, it's again 4 times 2, so 8. I'll have to look out. This is the submission, right? Let's look at the solution. Where is Python? Explanation with pictures. Okay, for TTS, text to speech initialized. Wait, what's TTS? Body text to speech. Initialize the length of the input array to num. There is no explanation. Oh, wait, this is the explanation. Right. Proof of its authenticity. Okay, if you click on the screenshot, get proof of its authenticity. Please upload welcome to the solution. Initialize the length of the input array nums to n. Yeah, it is not. If you are okay. Vectors, similar to finding perfection. Simplification array. Looks like I'll have to look at this solution from leetcode. It has a video over here, right? Where is it? You on YouTube.
Hey everyone, welcome back, and let's write some more.
Let me increase the volume a lot so that I don't. Here's when I put the microphone over here. That's fine, right? Yeah. All right. Okay. So
More neat code today. So today let's solve product of array except itself. So this is another problem from the blind solution today, and we're getting one step closer to having every problem in this entire list filled out. So for this problem, we're given an input array of integers nums, and we want to return an output array for every single number that we're given, where for each value in the input array nums, we're basically multiplying every single number except that value and then returning that as the result. For example, in this example, you can see we're given 1, 2, 3, 4. So for example, for this value 1, we would want to return the multiplication, the product of every other value. So for these three values, the product would be 2 times 3 times 4. That's going to be 24. So for the first value in the output, we're going to put 24. Similarly, for the second value, we want to multiply every value in nums except for this value. So that's going to be 1 times what they give us, the division operator. For product so if we wanted the product of every value in here except the 3, one way we can break it down is basically get these two values together, and then that's going to give us the value that we want to put in this position in our result. So it would be helpful for us if we want to do that for every single value in the input array, if we basically just compute the prefix product for every single position in the input array, right, and then put it in a prefix array. And since we're also going to be wanting to...
Oh. Yeah, that's all it took. It took about a minute to properly understand the problem after watching this video. Erase that. Erase the an integer array name string array answers that answer I is equal to the product of all the elements of any subscript. So prefix equals and so let's say and now for since these are the revision problems, I don't really need to find a solution for it from the beginning, right? So I should just watch the video first.
The product of values after. It would also be helpful if we computed the postfix product of every single position in the entire input array, right? And we can compute both of these in big O of n time. It's a pretty simple algorithm, right? We basically start the first position. Okay, this is going to be 1. So if we're adding this value, we're just going to take the previous value and multiply it by 2. So this is going to be 2. Similarly, we're going to take 2, multiply it by 3. We're going to get 6 here. 4, multiply it by 6. We're going to get 24. And for postfix, we're basically going to do the exact same thing and do it in reverse order. So here we would get 4. Here we would get 3 times 4. Here we would get 2 times 12. And then here we just get 1 times 24, which is just going to still be 24.
Yeah, it's that easy, I don't think. Let's look at all of that. Things equals then runs prefix I equals prefix I correspond times I prefix A is prefix. Let's use say we start from n, go up to 0 minus 1. Okay, prefix j equals prefix no, it's suffix. Let's see suffix. 2 plus 1 I like this is I one so for the suffix we start from the end. So for 2 we've got 4 and 4 times is n and minus 2 n minus 3 minus 2. Okay, start from n minus 2, so surface is at so the suffix is at 3. So 3 plus 1 is 4 times minus 1. Yeah, let's watch the video again from start.
Now for every single value, for example, 1, we would want the prefix of every value before it. Now since we can get that in the position to the right. For this one, we do get 24, and then we just repeat the exact same process. We also want the postfix of every value that comes after it. We can get that in the position to the right of 1. So we want to multiply those together, so 1 times 24. So in the output for this here, we want the prefix applied except for memory, but we can actually use this idea because what they tell us is the output array does not count as extra memory, so we actually don't need these prefix and postfix arrays because we can compute these, and we can compute these prefixes and postfixes and then store them in our output array, and that is going to end up making things. We're going to start at the beginning and then go all the way to the end, basically computing its prefix memory. So what we're going to do is we're going to do 2 passes on our input array nums. First, we're going to start at the beginning and then go all the way to the end, basically computing every single prefix for the input array and then storing the prefix. So for example, the prefix of this is going to be stored over here, right? Because that prefix is needed to compute the result for this position. And so at that point, what we're going to say is every prefix is going to be in the output. Basically, the prefix over here is going to be stored in the second position. The prefix over here is going to be stored here. The prefix from this is going to be stored here. And remember how for the first position, there is no prefix, so we're going to put a default value of 1 over here. And then after that, we're going to do a pass going from the end to the beginning, computing every postfix. So for example, this postfix, and then in the result, we're already going to have the prefix stored over here. This prefix, right? The first 2 values is going to be stored over here. So what we're going to do is we're going to take this prefix and multiply it by whatever is in this position. That's what's going to give us the result that we want for this position. So let's start off. So far, the prefix that we're going to be at is just going to be the default value of 1. So we're going to put a 1 over here. Then we're going to multiply it by what value comes over here. 1 times 1 is going to stay 1. So we're going to leave our prefix as it is. Now we're going to be at the second position. So what we're going to do is take our prefix, which it basically tells us the prefix up until this point. We're going to take that and then put it in the output. So 1 is going to be here. And then we're going to take the value that we just reached, multiply it by the prefix. So now the prefix is going to be a 2. 2. So now we're going to be at the third position. So what we're going to do is take our prefix up until this point and go ahead and put it in the output. So 2 is going to be placed in the output. Then we're going to take the 3 and then multiply it by 2. That's going to give us a 6 for the prefix so far. So at this point, we're going to take our prefix 6. It tells us the prefix up until this point. So we're going to take it, put it in the output. 6 is going to be put in the last position. Then we're going to multiply 4 by 6, which is going to give us 24. But that value 24 is not going to be put anywhere because clearly we have run out of room to put it. So we don't need to store it in the output. So now we visited every single value from the beginning to the end, computing the prefixes and then putting them in the output array. So now we're going to start at the end and go to the beginning and do the exact same thing, except we're going to be doing postfixes, which are basically starting from the end of the input array and computing the products. Once again, the postfix is initially going to be set to 1. So what we're going to do is take the 1, which tells us the postfix up until this point, basically an empty thing. And that makes sense because for this value 4, we would want the prefix of it as well as the postfix. But there is no postfix, so that's just going to be a 1. So we can take that 1, multiply it by 6. So 6 is going to stay the same. So that's going to be the result value for this position. But then we're going to take 4 and multiply it by the 1 in our postfix. So our postfix is now going to be 4. So we visited this position. Now we're going to be at this second position. So we're going to take our postfix, which tells us the postfix up until this point, and then multiply it by the 2 that's in this position. So 4 times 2 is going to give us an 8 for the output value. Then we can take this value 3, multiply it by our 4, which is going to give us a 12. So now we visited this value. Now we're at the next value 2. So we're going to take our postfix up until this point and multiply it by the 1 that's here. So this is now going to be a 12. And we can also take the 2 and multiply it by 12, which is going to give us 24, which tells us the postfix up until this point, which is going to be useful for us because we know that if we want to get the 4 now, and that's the entire result. So we basically did the exact same thing that we did with our brief time complexity, big O of 1 memory complexity. Now let's jump into the code. So the first thing we're going to do is create a result output array. So this technically does not count as extra memory in the context of this problem. I'm just going to give each position an initial value of 1, and we want this to be the length of the input array, so we can multiply it by the length of nums. So first we're going to be doing the prefixes. So I am going to initialize prefix as 1, and then we're going to go through every position in our input array. So for each position in our result output array, I, we're going to take that prefix and then just put it in that position I, right? And then after we've done that is when we're going to take the input array value, nums of I, and multiply it by whatever the prefix happens to be. So prefix is just going to be multiplied by this value. So that's how we're going to be computing the prefixes as we iterate through the input array nums. And we're going to be storing the prefixes in the result output array. After we've done that, we're going to do the exact same thing with the postfix array. Well, almost the exact same thing. So we're going to start at the end of the input array and then go up until the beginning, and that's how you can do this in Python. And so in this case, the result of I, we're not just going to be simply storing the postfix value because we know that would end up overwriting in the result whatever the prefix we stored was. What we're going to be doing with the postfix is we're going to be multiplying it by the value that's already in results because that's simply multiplying the prefix and the postfix together. Once we've done that, we know we do have to continuously update the postfix. So with postfix, we're just going to multiply it by whatever value happens to be in the input array nums. And once that is done, we're actually done with the entire problem. Then we can just return the output array result. So this is pretty much the most efficient way to solve this problem. As you can see, best memory complexity, best time complexity as well. So I hope this was helpful.
Oh, it's a bit different than what I did previously. It seems like I didn't well watch the entire video when I previously attempted to solve this problem. Yeah, what he does is way simpler than what I did previously. So here he has result I equals prefix. I equals prefix. So prefix is 1 and I means then result I equals prefix. Prefix equals prefix times then the I wow. That's just you made this problem way simpler than what I had like previously understood. So it's very simple. Let's reload it to see the first time. So it's if x equals 1 for r and range and equals none results equals 1 times none. Okay, equals 1 for r and range and results then prefix prefix equals prefix is odd. Prefix equals prefix times so okay postfix equals 1 origin means n minus 1 is moved up. I would like to do the array just in order. Once j equals postfix was six then 1126 now still postfix equals 1 this is the n minus 1 comma minus exactly is what is doing except that is using different variable names rather iterative variable announcing that's not my problem. ChatGPT.com. Let me ask let's okay range this is exactly the same as what I was scared of. And that's 1 was case of having no space between the minus and the 1, but it was not. There's another problem. Uh, is 2 equals postfix. I says those prefix it's exactly the same. What the hell? I believe should be there. It's from rooms n minus 1 Yeah. Oh, I forgot. Come on, my bad. It wasn't here. So it's 34% of the submission is, and it's not even faster than laptop previously. But that's fine. It's 1 o'clock right now, and I've got 10% charge. Yeah, so guys, that was it for today. I only did a single revision quiz problem, but off camera I was solving this. Let it load. Yeah, it's a today's TV problem. Spent about I don't know, maybe around 10-20 minutes on it, and I will solve it today. Yeah, I solve it, but I'll solve it off camera because I only have a 10% size. I could charge my laptop, but I could do that, but uh, yeah. I'm not going to stream if it's time for my lunch. So yeah, that's it for today, guys, and I'll see you guys tomorrow with another revision problem. I'll try to guys solve the problem till I am confident enough to like solve all of them within the 10 minutes or so, which is probably gonna take me uh, 20 more days or something like that. Yeah, that's it for today.